So the pop quiz, question one. Any doubt?
No, sir.
The question number one, what is designed to change the electrical energy to kinetic energy? Like which intake energy, electrical energy or electricity, and moves. So the motor takes electrical energy, like when you switch on, it takes electrical energy and start to rotate or move, so convert into kinetic energy. The next we have question two. The power station uses nuclear fission. Anyone having a doubt in this? Question two. If no
No,
doubt, then
sir.
okay. So I will just state the answer. If in case if you have a doubt, I will explain that. So the correct answer for this one is D, that it convert the nuclear energy into internal energy, or we can also say the heat energy. Question three, any doubt?
No, sir.
A ball is released from a rest and rolls down a track from a position. What is the furthest position the ball could reach? Because we know energy cannot be created nor be destroyed, but it transforms from one form to another. So if we have initially like a GPE, gravitational potential energy, as the ball rolls down, it will lose some of its energy. So when it will lose some of its energy, if there was no energy loss, then it can reach the same position. If we have like a surface which does not have any friction, or we have a vacuum, so the air resistance or a drag is negligible, no air resistance or a drag, so in that case it will rise to the same height. But because in realistic, what will happen as a ball roll down, it will lose some of its energy. When it lose some of its energy, so it will not rise to the same level, it will rise a lower level than from where it is released. The same concept, like if you have a ball and you drop a ball from a certain height, so when the ball hits the ground, the ball will bounce back, but it won't bounce back to the same height. Why it does not bounce back to the same height? Because when it hits the surface, it loses some of its energy. So because of the energy loss or losing some of its energy, that's why B will be the right answer here. Question 4, any doubt? Question 4, any doubt? Okay. In which type of power station does not use steam from a boiling water to generate electricity? So if we take example of a geothermal, in a geothermal, what will happen? The energy from the hot rocks absorbed by the water, and the water turn into steam. So the water turn into steam, and then as a result, steam rotate the turbine to produce electricity. So it means the geothermal is using the steam, because first the energy from the hot rocks is absorbed by the water, that is converting into steam, and then steam is rotating a turbine, moving a turbine to produce electricity. Hydroelectric, in hydroelectric, what happened? In hydroelectric, we don't boil the water. In hydroelectric, what we do? We store the water behind the dam. So the water is stored behind the dam at a certain altitude. It will have a gravitational potential. When we allow the water to flow, this water, flowing water, will rotate the turbine. And as the turbine rotates, what it will do? It will produce electricity. So in a hydroelectric power station, we are not boiling the water. We just use the gravitational potential energy of a water, which convert into kinetic energy of a water or a turbine, and then produces electricity. That's why B will be the right answer here. Same thing for a nuclear also. In a nuclear power station, first a nuclear energy convert the water into steam, and then steam rotate the turbine to produce electricity. So by a nuclear fission, like we carry out a nuclear fission here, which releases the energy that convert the water into steam and rotate the turbine to produce electricity. So that's why it cannot be C. Why not A? Because geothermal energy, the energy from the hot rocks, so this energy, heat energy from the hot rocks, convert the water into steam. And when the steam rotate the turbine, turbine rotate and produces electricity. So nuclear, oil fired and geothermal, all the cases, we convert the water into steam. But in hydroelectric, we just use the flow of the water, which is released from a certain altitude or a height to produce electricity. But we don't boil the water or convert into steam. Question 5. A man standing at the top of a cliff throws a stone. Which form of energy does the stone have at X and at Y? So you can see the stone, the stone is released. So stone is moving. Moving object will have kinetic energy. The stone is also at certain altitude or a height, so it will have a gravitational potential energy. Same thing at position Y, the stone is also moving. So it possesses a kinetic energy. And it is at certain height above the ground, so it will also have a gravitational potential energy. That's why D will be the right answer here. Question 6. Any doubt which form of energy do we receive directly from the sun? So we receive the light energy directly from the sun. Any doubt in question 7?
No, sir.
Look, in question 5, yes, I will repeat question 5. In question 5, a man stands at the top of a cliff, he throws a stone. You can see the man throws the stone. So at position X, the stone is moving because the stone is going down, so it's moving. Anything which is moving, which energy it will have if it's moving? It possesses a kinetic energy because moving objects always possess a kinetic energy. And the stone is at a certain altitude or a height. So which form of energy it will have? It will also have a gravitational potential energy. At position Y, the stone is also moving. The stone is also moving. So if it is moving, which form of energy the moving object possesses? If it is moving, it possesses a kinetic energy. And because it is at certain altitude or a height, so it will also have a gravitational potential. That's why D was the right answer for this, that it possesses kinetic and gravitational potential energy at both positions X as well as at Y. In question 7, a laborer on a building site lifts a heavy concrete block onto a lorry. He then lifts the light blocks same distance in the same time. Which of the following is true? Look, what about the work done? Work done depends on two factors. Work depends on force and it depends on time. Because first he was lifting the heavy concrete block, so means he was applying a greater force. Then he lifts the light block. When he's lifting a light block, means he's applying less force. So what happened to work? The distance is the same, like he's lifting to the same lorry, but first he was lifting the heavy blocks, heavy concrete block, then he's lifting the lighter concrete blocks. So the distance he moved is same, but the force has changed. The force has reduced when he's lifting the light blocks. So it means what happened to the work? The work done will also decrease or less. What about the power? The power depends on two factors. It depends on work and it depends on time. He is using the same time dimension, so time is not changing. But what happened, because when he's lifting the lighter object or a lighter block, so the work done will be less. So if less work is done, what about the power generated? The power generated will also be smaller. So the work, because the work is decreasing, so the power will also decrease. So work done in lifting the block, it will be less for the light, and power exerted by a laborer, it will be less for the light block. So A will be the right answer. Is it clear?
Sir.
Question 8, any doubt? Which source of energy uses the production of steam to generate electricity? So as we discussed in a nuclear, by a nuclear fission reaction, it produces heat energy which convert the water into steam and rotate the turbine to produce electricity. So in nuclear power station, we convert the water into steam. In nuclear, in oil fired or as well as geothermal, we convert the water into steam to produce electricity. Question 9. A cyclist travels down a hill from a rest at point X. So if he is at rest, so what about the kinetic energy? So the kinetic energy will be zero because he's not moving, but he's at certain height. So when he's at certain height, he possesses a gravitational potential energy. Then the cyclist, without a pedal, he moved down and he then applies the brake and stop. So when he stop here, means that he's also at rest. So what happened to kinetic energy? The kinetic energy will also be zero. What is the change in energy? So what about the change in energy? We know at position X, so he possesses a gravitational potential energy. When he's rolling down, like moving down, it means he's moving from X to Y, so he possesses a kinetic energy. But he stop here, so which form of energy he will have? He will have heat or internal energy. Because when he applies the brake, most of the energy is lost to the surrounding in the form of heat. So first he possesses a gravitational potential at X. Then when he's moving from X to Y, he possesses a kinetic, but at Y he stopped as he applies the brake. So all of its energy loss in the form of heat or internal energy. So D will be the right answer. Question 10. Which form of energy is used to generate electrical energy in the tidal power station? In a tidal power stations, we use the change in the water level, the high and the low tides. So whenever there's a change in the level, which form of energy it will have? It possesses a gravitational potential energy, which we also call GPE. Which line in the table gives an example of a stated form? So gravitational potential, The energy due to moving train, no, that's not a gravitational potential, that is kinetic energy. Internal, the energy due to a flow of a cathode ray or electrons. So when anything is flowing, it possesses a kinetic or moving or charged particle, electrical energy also, because electrons are there. Or you can also say kinetic, but not internal. The energy due to the position of a swimmer standing on the high diving board. So this is not a kinetic, this is a GPE, gravitational potential energy. The strain energy, the energy due to compression of a spring, when anything compressed or stretched, deformed, which form of energy it will possess? Which form of energy it will
Plastic.
possess? It will possess a elastic strain energy. So D will be the right answer. Question 12. A person uses a chemical energy to run up some stair. She stops at the top of the stair. When has the chemical energy been converted? Uh, like what has the chemical energy been converted to when she's at the top of the stair? So she stops. So if she stops, what about the kinetic energy? She does not have any kinetic energy because moving object possess kinetic. So means any option with kinetic cannot be correct. And she's at certain height above the ground. So which form of energy she possesses? She possesses a gravitational potential energy. So kinetic is not there because they already mentioned that she is at the top of the stair. She stops at the top of the stair. So this statement is there, which give an indication that there is no kinetic energy. So no kinetic energy. So gravitational is there because of the change in position or height, and heat energy is there because like the body loses heat energy or loses energy in the form of heat. So C will be the right answer. Strain energy will be there if there is a deformation. Like example, let's say she reaches the top and she sit there or she stretches there, then she will possess a strain energy. Question 13, the electrical energy may be obtained by nuclear fission. In what order is the energy transfer in this process? First, we have a nuclear fuel, then we have a reactor and the boiler. So then we have a reactor and a boiler in which the water boils. And then the turbines are there which rotate, like the steam rotate the turbine, and turbine connected to generator which produce electricity. So first a nuclear fuel, then a reactor or a boiler is there in which the water absorb the energy, turn into steam. Then steam rotate the turbine, and the turbine connected to a generator which produce electricity. The question is, in which position does the stone have the greatest kinetic energy? Kinetic energy depends on what? We know kinetic energy is half mv square. It depends on the mass and speed. Mass of an object is not changing, but the speed does change. So which position, 1, 2 or 3 will have the highest speed? Which position? Is it 1, 2 or 3? When you throw something, at which position you think will have the highest speed?
At 3.
At 3, because when it is coming down, it will have the highest speed. So if it is having the highest speed, so it means which form of energy, like the kinetic energy will be maximum. So greatest kinetic energy, which position will have 3? Least gravitational potential. Gravitational potential energy, which is mgh, depends on mass, gravity and height. If we have, like, the least means the mass is not changing, gravity we consider it to be a constant. So if the height decreases, the gravitational potential energy will also decrease. So which position, 1, 2 or 3, the object is having the least height, because we need the least gravitational, so the height should be minimum. So which position the height is minimum? At third position, the height is minimum. That's why D will be the right answer for this one. Question 15. A worker is lifting boxes. A worker is lifting boxes of identical weight from a ground on a moving belt. At first, it takes 2 seconds. Later in the day, it takes 3 seconds. Which statement is correct? Look, one thing, remember one thing, work depends on what? Work depends on force and distance. So if a worker is lifting the box from a ground to the belt, so if a worker is lifting a box from ground to the belt, uh, first he was taking 2 seconds, but later in the day he's taking 3 seconds. But when we compare the work done depends on the force and it depends on the distance. He's lifting the identical boxes, so the box is not changing. And he's lifting them to the same height, but different time interval. But the work does not depends on the time. So it means the work done will be same. Even if he's taking 2 seconds or 3 seconds, the work done is same. As work done does not depends on time. It depends on the force which we apply to do a work. It depends on the distance we moved. But what about the power? The power is work divided by time. Later in the day, he's taking 3 seconds. So if he's taking 3 seconds, so what happened to the power? Then the power will be reduced. Like if I take longer time to do a same work, it means that the power will be less. So later in the day, less work is done. No, that's wrong. Later in the day, more work is done. That's also wrong because we are doing the same work done. Later in the day, less power is developed. That is right because we are taking longer time to do the same work done. So it means we develop less power. So remember, power depends on the time, not the work. So this was a pop quiz, MCQs pop quiz 12.
Sir, what will be